All right, good morning, guys. So today we are going to start a completely new topic, right? We'll be spending the next 9 or 10 periods talking about our laws of exponents, which will continue to develop basically all throughout high school, but we're going to basically learn the basics. We're going to talk about what happens when we multiply and divide powers of the same base, and we're going to start by looking at what we call negative exponents as well as zero exponents, right? So we don't need to tackle the do now, but let's start with the zero power. Right, so let's say we have a number, any number, right, to the zero power. And usually what happens in class is I will say, hey, does anyone know what happens if I raise something to the zero power? And of course I'll have some people that will say 0. And then someone's going to say 1. I'm going to say, great. Why is it 1? And nobody has any idea, right? Some people know it's 1 because a teacher or their parents or whoever told them it's 1, but we don't really understand why. So what we're going to do at the beginning is we're going to derive where that comes from so that rather than just have to memorize it, we know where it comes from. And we're going to use that derivation to extend a little bit further and get into what we call negative exponents. So what we're going to do is we're going to make a little table. We're going to make a list, right? So 10 to the third power, right, is 1,000. And 10 squared is 100. And 10 to the first is 10. So I usually will ask the question, well, what do we think that 10 to the 0 will be? And someone says, well, we're losing a 0 each time. And while, visually that's true, mathematically what's happening is we're dividing by the base. Now the base is what's being raised to the power, which in this case our base is 10. So what happens if I divide by 10 again? I get 1. Right? But some people just say, well, okay, that works for 10. Does it work with any number? So let's see, right? So 5 to the third power is 125. And 5 squared is 25, and 5 to the first is 5. So what am I doing? 125, 25, 5. I'm dividing by 5. I'm dividing by the base, which of course the base again is 5. And what happens if I divide by 5 again? We get 1. So ancient mathematicians, when they were trying to figure this out, this is what they used. And they made a little list like this, and they said, well, based on this, and they did it with all different types of numbers, positive numbers, negative numbers, fractions, decimals, and it always gave them 1. So what they said was, any non-zero number to the 0 power is 1. What happens when we do 0 to the 0 power? No one really knows, honestly. Most mathematicians think it's 1. There are some people that think it's undefined or 0. We don't really care. That's one thing that actually doesn't come up too much in mathematics. But we're certainly going to put this in our notes that anything to the 0 power is going to give us 1. Now, what if we want to use negative exponents, right? And we'll actually see fractional exponents you don't get into until probably second year in high school when we do geometry. So what happens if I was to continue this table a little bit, right? What's 10 to the negative first? And what's 10 to the negative second? And let's do the same thing with 5. Well, if you're telling me that we're dividing by the base, so 1,000 divided by 10 is 100, right? And then divided by 10 is 10, and then divided by 10 is 1. I'm going to divide by the base again. So 1 divided by 10 is 1/10. And 1/10 divided by 10 is 1/100th. And then 1,000th, and so on. Okay, what happens if we do that with a different base like 5? Well, if I divide 1 by the base of 5, I get a 5th. And if I divide that by 5, I get a 25th. And again, this is what these ancient mathematicians did when they had to derive their rule for negative exponents. And they said, well, interesting, right? My denominator is really just this without the negative, right? 5 to the second is equal to 25. 5 to the negative second is 1 out of 25, right? 10 to the first is 10. 10 to the negative first is 1/10. And what they figured out was the negative exponent is really just the reciprocal of the positive exponent. So if I had x to the negative 7th, that would just be 1 divided by x to the 7th, and that's how they derived these rules. So really important that we're all going to put this in our notes, right? That the rule for a negative exponent, right, a to the negative n, for example, is that we're going to do 1 divided by a to the n. It's literally just the reciprocal, right? The reciprocal is when we switch our numerator and denominator. The reciprocal of a positive exponent, and I gave you a couple numerical examples. 2 to the negative third is 1 divided by 2 to the third. 10 to the negative fourth is 1 divided by 10 to the fourth. So let's go through a bunch of examples. And guys, you can pause, you're going to take your notes, and then you're going to jump back on. 7 to the negative second. Okay, well, based on our rule, We said that that was going to be 1 divided by 7 to the second. 7 to the second is 7 times 7, which is 49, so 1/49. 2 to the negative fifth is 1 divided by 2 to the fifth. 2 to the fifth is 2 times 2 times 2 times 2 times 2, which is 32. And as always, guys, I know it's been a while since we've had the videos. You know, I am going to tend to go sometimes a little quickly on the videos just so that they're not super long. But you're just going to pause, right? If you need some more notes, if you need to go back to something, you're going to pause and go back to it. That's the one good thing about the videos as opposed to in class, is that you can always go back and you can go over something again. You can go back and take some more notes. 4 to the negative third is going to be 1 divided by 4 to the third, which is 1/64. 10 to the negative third is 1 divided by 10 cubed. 10 cubed is 1,000, so 1,000th. 6 to the negative first is 1 divided by 6 to the first, which is simply 1/6. Now, with the parentheses, guys, we have to be careful. So let's just kind of review, all right? So forgetting about this lesson on negative exponents, -2 in parentheses to the 4th power means I'm multiplying -2 by itself 4 times. Now, if it is not in parentheses, that means this is the opposite of 2 to the 4th. 2 to the 4th is 16. The opposite of that is -16. So this is just a little refresher on using parentheses versus not parentheses with negative numbers raised to a power. This has nothing to do with negative exponents. Okay, so that's just a little kind of refresher about what happens when we raise a negative number to a power. If it's in parentheses, you're multiplying it by itself that many times. If it's not in parentheses, the negative is not raised to the power. So you evaluate the power, and then you put the negative, you assign the negative at the end, because it's really the opposite of 2 to the 4th. Now in this case, the negative 4th power means I need to do 1 divided by, keep the parentheses, -2 to the 4th power. Now -2 to the 4th power is positive 16. So remember, guys, negative exponents don't have anything to do with negative numbers. A negative exponent just tells us take the reciprocal of the positive exponent, right? If you go back, we've done 6 examples. None of my answers have been negative, right? I've got 2 positive answers here, I have 2 positive answers here, and 2 positive answers here. Can I get a negative answer? Sure. If I got rid of those parentheses, now it's 1 divided by -2 to the 4th, which is 1 divided by -16. So it's not to say I can't get a negative answer, but the negative exponent really doesn't have anything to do with negative numbers. All right, so I don't want to spend too much time on this. This is more like a high school level kind of extension. But what would happen if I did 1/2 to the -4th? Well, that would tell me I need to do the reciprocal. 1 divided by 1/2 to the 4th. Now, what's 1/2 to the 4th? Well, it's 1/2 times 1/2 times 1/2 times 1/2, which is 1/16. So I need to do 1 divided by 1/16. So now we need to dig all the way back to 6th grade when we divide fractions. 1 divided by 1/16. How do we divide fractions? We multiply by the reciprocal. So we end up with 16. And again, guys, we're not going to do this one. That's not something I want to spend a tremendous amount of time on, but it really is something that we should be able to do. So there's your now try. So I know that you're all going to pause the video so that you guys can actually try this on your own. And then we're going to come back. So for the first one, 3 to the -4th is 1 divided by 3 to the 4th. 3 to the 4th is 3 times 3 times 3 times 3, which is 81. So we get 1 divided by 81. 10 to the -5th, I'll put over on the side here. 10 to the -5th should be 1 divided by 10 to the 5th. Now, evaluating powers of 10 is really easy, right? 10 to any power is 1 with that many zeros. So 10 to the 5th, and that looks a little sloppy. Let me clean that up. 10 to the 5th power is 1 with 5 zeros. So 10 to the 11th power would just be 1 with 11 zeros, as an example. 23 to the 0 power, I know you guys are all screaming, that's 1, right? Because anything to the 0 power is 1. Negative 2 to the 6th power, that's going to be 1 divided by, parentheses, negative 2 to the 6th power. Now, what's negative 2 to the 6th power? It's negative 2 times negative 2 6 times, which is positive 64. Now, what did we say? Well, if we want to get a negative answer, you need to make your base negative with no parentheses. So what's negative 7 to the negative 2nd power? Well, it's 1 divided by negative 7 to the 2nd power. Now, with those parentheses not there, we are not doing negative 7 squared. We're not multiplying negative 7 by itself. We are doing the opposite of 7 squared. So 7 squared is 49. The opposite of that is negative 49. So you get negative 1 out of 49, or 1 out of negative 49. Now, the only other thing we need to do is the reverse. So let's take a look at that now. Write the expression without using a fraction bar. So now we're working backwards, right? In other words, if the answer to our problem was 1 out of 25, how did we get there, right? What negative exponent expression would get us 1 out of 25? Well, we need to think about what 25 is as a power. 25 is equal to 5 squared. So what's 1 out of 25? Well, 5 squared would get me 25. So 5 to the negative 2nd power is going to get me 1 over 25. Because if I check it, what would happen? 5 to the negative 2nd equals 1 divided by 5 to the 2nd, which is 1 over 25. Great. So that tells me that 5 to the negative 2nd power is going to give me 1 out of 25. Now, I always have some lazy student that's like, hey, wait, can't you also do 25 to the negative 1st? And I'm going to say, sure, we can do that, but we really want to change the base. So if you're super lazy and you can't figure out another way to do it, you can just keep the base the same and use a power of negative 1. But in general, we want to think about changing the base. Let's look at the second, right? 1/8. But what do I know about 8? Well, the only way I can write 8 as a power with integers is 2 to the 3rd, other than 8 to the 1st, obviously. So if 8 is equal to 2 to the 3rd, then 1/8 should be 2 to the negative 3rd, right? That would give us 1 divided by 2 to the 3rd, which is 1/8. Now, 1/16 we can do in a few different ways, because I know a few things about 16. I know that 16 is equal to 4 squared, but I also know that 16 is equal to 2 to the 4th. Well, that means I can write 16 as 4 to the negative 2nd, or I can also write it as 2 to the negative 4th. Right? 4 to the negative 2nd is 1 divided by 4 to the 2nd, which is 1/16. 2 to the negative 4th is 1 divided by 2 to the 4th, which is also 1/16. All right, guys, there's your homework. The first 6 are what we did the majority of the lesson, evaluating those negative powers. 7, 8, 9, and 10 is what we just did a minute ago. Rewrite those expressions without using a fraction bar. The more you can do, the better. So for 7, 9, and 10, there's only really one other way you can do it. For 8, there's actually a bunch of ways you can do it. There's 3 good ways, plus that kind of cheap way with the negative 1st power. So guys, as always, any questions, comments, concerns, you upload your work, you post some comments on Google Classroom, and we can chat about it.